well, actually, I should say Chapter 8, we're going to do exponents and roots. And I will tell you ahead of time as we move into Lesson 8.1 here. 8.1 is very definitely a review of previous understanding of exponents. So if you think that you have done this part before, you probably have, okay? So we're going to review our meaning of exponential notation. We're going to translate to and from exponential notation. We're going to evaluate expressions with exponents before we go on to the next level of exponents. So let's, again, review our meaning of exponents. Exponents are used to represent repetitive multiplication by multiplying the same factors over and over again. Okay, and remember here, and again I'm going to go quick because this is review, we have our base, and that is the number that is being multiplied repetitively, and we have the exponent that tells us how many times that number is being multiplied together. So 3 to the 5th power means 3 times 3 times 3 times 3 times 3. It does not mean 3 times 5. If we wanted it to say 3 times 5, we would simply say 3 times 5. So as we move forward, again, and I am going quickly because this is definitely review, 2 to the 6th power means 2 times 2 times 2 times 2 times 2 times 2. So when I multiply all those 2's together, I then have my solution. Okay, I'm not going to worry about the solution in this particular case. We'll get to that later. 3 to the 8th power is 8 3's multiplied together. So you'll need to notice all of these 3's multiplied together. And again, 3 times 3 times 3 times 3. This is not 3 times 8. And conversely, 8 to the 3rd power is 3 8's multiplied together. Not 3 times 8, because 3 times 8 would be 24 if we were doing that. 8 times 3 would be 24. And this and this, these two things are not equal to one another. Alright, so here we go. 4 times 4 times 4 times 4 times 4. If I write it as an exponent, is 4 to the 5th power. There are 5 of them. 4 to the 5th is 1,024. 6 times 6 times 6, well, that's 3 6's multiplied together, which is 6 to the 3rd power, which would end up being 216. 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1 to the 7th power. This is not 1 times 7. This would end up being 1. 7 times 7 is 7 squared. 7 times 7 is 49. Again, this is not 7 times 2. 7 times 2 would be 14. 7 squared is 49. 5 to the 4th power, well, if this was 5 times 4, that would be 20. But 5 to the 4th, when I multiply all those 5's together, is 625. And then you'll notice here I have 7 2's multiplied together. 2 to the 7th is 128, not 14. Okay, also as a review, we do have some special numbers, some special exponents. So 4 squared would be 4 to the 2nd power. And this idea of squared comes from our areas of shapes. Okay, so when we take the area of something, we are trying to figure out how many square feet fall into it, usually square feet if we're doing things in feet, length times width, and so on. Cubed is things to the 3rd power. That's when we're doing volumes. Okay, so 2 is squared, 3 is cubed, again, area, volume. But then when we get to our other powers, we just say to the whatever power. So in this case, I've got the 6th power. It could be the 8th power, 14th power, whatever. Okay, so let's go ahead and write a few things in exponential form real quick. 5 to the 1, 2, 3, 4, 5, 6, 7. Sorry, 7. I counted 7 and then wrote 6. 7. 1, 2, 3, 4, 5, 6, 7, and again, this would not equal 35. Our answer here would be much bigger, okay? Negative 4, and I will put it in parentheses, to the 3rd power. And the reason I will put it in parentheses, this is a side note, if I just write this, the power would only apply to the 4 and not the sign, okay? And in some cases, doing that will change the outcome. So when I have that negative there, I am going to definitely include parentheses around it so that I include the negative and the 4. Alright, now we have broken into parts, so we're just pretty much going to split this. We're going to deal with those and put those together. So 8 to the 4th power times, and then in this case, okay, e to the 3rd power. Now in this particular case here, I'm going to go ahead and leave out the multiplication sign because we know if we write these together without a space, it means multiply. Now if you wanted to put a dot in between them, you could. It wouldn't change the meaning. You could put them around, parentheses around each of them if you wanted to. That would also keep the meaning, but you don't need to. Those are just extra characters that you don't have to have. Alright, now we're going to go ahead in this particular case and we are going to calculate the value of these. So 3 to the 4th, and I'm going to go ahead and in this particular case, I'm going to write out what it happens to mean. Probably in many cases you could put this in a calculator, but if you don't happen to have one, this might be a quicker way for you. 3 times 3 is 9. 3 times 3 is 9. If I then multiply those 9s together, 9 times 9 is 81. Alright, so, or you can go 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. 1/4 squared means 1/4 times 1/4. Okay, and we know in our order, or in our multiplication of fractions, we look for reductions. There are none. 1 times 1 is 1. 4 times 4 is 16. All right, moving on. Negative 8 to the 2nd power means negative 8 times negative 8. Okay, 8 times 8 is 64. A negative times a negative is positive. Positive 64. Again, this is one of these here where we have to realize that the power in this case is only applied to the 2. It is not being applied to the negative. If we wanted to apply it to the negative, we would put parentheses around the 2, the negative 2, sorry. So what this actually means is negative 2 times 2 times 2. Okay, so we're going to raise the 2 to its 3rd power. 2 times 2 is 4, times 2 is 8. And then we are going to apply the negative. So negative 8 in this particular case. And then we can evaluate through substitution. So I'm given some variables and I'm given some value of the variables. So I'm going to go ahead and I'm going to substitute these values in to the appropriate spot here. So x is a 20, y is a 4, got some parentheses, z is 2, times y is 4, z again is 2, that's a power. And I'm going to go ahead and use my order of operations. Please excuse my dear Aunt Sally. So I start inside the parentheses, and I go multiply or exponent. Well, we know exponents come first, so 4 squared is 16. And I will go ahead and bring down everything else, okay, that I haven't used yet. Still inside the parentheses, I've got 2 times 16, which is 32. Alright, so again, bringing down everything that I haven't used yet. Subtract or multiplication. Well, multiplication comes first when in our order of operations. So in this particular case, we've got to do 4 times 32, which is 128. And now I can do 20 minus 128, which I know already will be a negative. 128 then minus 20 is 108, 108, and that is a negative answer. When I take something bigger out of a number, I run into the negatives. So. And then the number of diagonals of an n-sided figure is this formula. So this will create calculate the number of diagonals. Use the expression to find the number of diagonals for a 6-sided figure. And n in this case is the number of sides. So I'm going to go ahead and I'm going to replace n with 6 in each of these cases. Now remember, this is multiplication. No space, multiplication. Alright. So then we use our order of operations. Well, inside the parentheses, I've got an exponent, I've got subtract, and I've got multiply. Exponents happen first. So we have 36. And again, bringing down that 6 a little better. right, still in the parentheses, subtract or multiply. Well, multiply happens the first of those two. 3 times 6 is 18. All right, oh, sorry, I forgot my half here. Okay, and then obviously the only thing left in the parentheses at this particular part or point is the 36 minus 18, so I'm going to subtract those. That is 18. And then 18 times 1/2, and if you want to go through the whole steps of cross-reducing and things, you can, but I know if I multiply by a half, that takes the number and cuts it in half, so half of 18 is 9. So the number of diagonals in this particular figure will be 9. 9 diagonals. D-I-A-G-O-N-A-L-S. Diagonals. And if you want to know what a diagonal is, it is, well, let's see if I can do a 6-sided figure here. Okay, supposed to be a 6-sided figure. A diagonal is a line that happens to cut across a figure. So in this case, if I were to go from that corner to that corner, that would be a diagonal. Again, very poorly written or drawn picture, but all right. So time for you to review your lesson 8.1 and your exponents. Obviously, come see me if you need help. Otherwise, good luck.